Hello everyone, you're welcome to my channel today. Okay, so in this video we are going to be starting another series of solution to exercises. Now if you check the description of it's another playlist. Okay, so if you check the description of that playlist, you see where I describe that it's exercises from the university where I teach. So I'm going to be considering the topics which are in the description of this live section. Okay, so it's particularly pre-calculus. Okay, so we are going to be covering topics on pre-calculus. Okay, so which includes majorly four major areas. Okay, so the first being from topics on functions. Okay, so we're going to be seeing topics on functions, which will include what is a function, introduction. Okay, and then you are going to move away from there, and then you begin to talk about evaluation of a function. Okay, so under introduction you will see what a function is and what a function is not. All right, permit me to write functions in this short form, and then here you are going to look at evaluation of functions. If you are given a function, for instance f of x equal to say 2x, all right, and you're asked to evaluate f of half, what does that mean? Okay, so this is what evaluation of functions is all about. And then under here, after this you're going to consider stuff like composite functions. That means how do you take the composition of functions? Okay, so if a function is given, or two functions or three functions are given, how do you take their composition? All right, and after that we are going to look at the concept of inverse of a function. Okay, so we look at inverse of functions, and after inverse of functions we will consider what we call limits of functions. Okay, so there we are going to dwell a little bit how to look at the limits of functions, and of course there are different forms. So you are going to see limits of functions as normal evaluation of functions, and then you are going to see what we call L'Hopital's rule. Okay, so the L'Hopital's rule, of course, it comes under limits of functions. However, it's actually an application of differentiation. So you are going to be learning differentiation to be able to do L'Hopital's rule. And then of course these are the basic things you will see under functions. Okay, and then remember I said there are four major parts or areas under this particular course. So the first is functions. Now the second is differentiation, what you may call differential calculus. Okay, so under differentiation we are going to be seeing different topics as well, so which will include stuff like you will see differentiation by first principle. So you see first principle. All of these topics I'm going to bring maybe on this channel. All right, then after first principle you will see techniques of differentiation. So under the techniques of differentiation you are going to see the different techniques, which will include the different rules. There are about three basic rules. So we have the product rule, we have the quotient rule, and then we have what we call the chain rule, which some people also call function of function rule. And after these rules we are then going to see, okay, of course under the techniques of differentiation we are going to see what we call standard derivatives. Okay, so the standard derivatives will help us know how to differentiate the different kinds of functions that we have, which are of course we have the what we call the polynomials. Okay, so how do we differentiate polynomials? And then we now come to transcendental functions such as the trigonometric functions, how to differentiate sine, cosine, tangent, and then other inverse functions, and then also how to differentiate the exponential functions, the logarithmic functions, and so on. So we'll see all of that under standard derivatives. Okay, so and beyond all of this, we are then going to look at the applications of differentiation. So there you are going to be seeing concepts such as minimum point. So you see minimum point, which we also call minima, and then you talk about maximum point, which you can write as maxima, and then you have what we call point of inflexion or the inflexion point. Okay, so and then we also look at distance between points as one of the applications of differentiation. Okay, so and that is going to be all under differentiation. And then the third one, which is integral calculus or integration. Okay, so under integral calculus, we are going to see basically how to differentiate different functions. Let me call it what I call standard under differentiation. I call them standard derivatives. So here you can call them standard integrals. Okay, so meanwhile, before the standard integrals, we also have technique of integration. Okay, so integral techniques. So all of them will, go together. Techniques of integration. Okay, so after that, you are now going to see all the different techniques. You have the one we call the U substitution. You have integration of the type of the form. Okay, there are some integration or some functions you'll be given if they satisfy a particular form. For instance, there's the one we have f prime of x all over f of x. So if you have a fractional function, what you can also call rational function, that satisfy this form, then there is an approach we use in differentiating such functions. And then we have integration by partial fractions. Okay, so there are some integrals that you will need to split into their partial fractions to be able to differentiate, to integrate them. And then after that, we have what we call integration by parts. Okay, so this one is the reverse of the product rule under differentiation. Okay, so and then we also have application of integration such as areas and then volumes and the rest of that. Okay, so and etc. So the integration or integral calculus are not that much. Of course, the whole course in general is not that much. However, you must have a calculus background, maybe from the secondary school, and if you don't, you just have to pay attention. There is nothing very serious here. And then the fourth one, which is the last, is what we call the conic sections. Okay, so under the conic sections, we are just going to be learning equation of different conic sections. So it's going to include equations of lines, straight lines, equation of circles, equation of ellipses. Okay, so we look at ellipses, then we look at equation of parabola, equation of hyperbola. Okay, so these are the basic conic sections that we are going to be considering, about 4 of them, then including straight lines that we'll consider in this course. So everything you're going to be seeing in the exercises that we are going to solve, which for me I believe should just be a review of the entire course for you. So as we go through the exercises, you're reviewing the entire course, and it gives you a picture of what to expect in the course, all right, generally. Okay, so I'm going to be going to a new page as we begin these exercises. And of course, we are going to begin the exercises from module 1. There are about 2 modules of the exercises that we're going to be working with. And I'm beginning with the module 1. Okay, so and module 1 has about 11 questions, 11 exercises. Okay, so depending on how fast we are, I would not want these exercises to get beyond an hour or far beyond an hour. So depending on how fast we are able to cover, then we will know whether we are going to finish the whole of the module or we are going to continue in another section. Okay, so let's begin with question 1 of module 1. Okay, so and I'm going to be responding to the questions according to the structure on the material we have. Okay, so the first question says, so meanwhile, the reason I gave the breakdown is so that you will know that these exercises or videos we are going to be doing on this playlist is not particularly for only the students of my school. All right, anyone can actually benefit from what we are learning here, because there are concepts of mathematics, topics of mathematics. Everybody learn functions, everybody learn differentiation, integration, conic sections, and all of that, circles, lines, and what have you. So you are, of course, it's something you will benefit from. Okay, so and that's why I will also be writing the questions from this material, so that you will know that they are topics that you should also benefit from. Okay, so the first question here says, find the domain of the function. And here is the function. Okay, and this is another very important part that I omitted here. Domain of functions. Oh my God, domain and range of functions, very important. Okay, and I even didn't put it in the description. I'm going to do that at the end of this particular section. Okay, and here is the domain of the here is the function we are given: x plus 2 all over x squared minus 4. Okay, so now I'm going to lead you through how to deal with domain of functions, and then I'll particularly come down to how you are going to, fill up or, deliver the solutions that you would need when you are asked. Okay, so what do we do? First of all, when it comes to the domain of functions, if you are given, especially let's talk about fractional functions. If you are given a fractional function, let's say f of x all over g of x. Now the domain of this function, which I can write as dome of f, is always equal to the values of your g of x, the values of x, such that my g of x will not be equal to 0. That is the domain of this function. Meanwhile, what is domain? Domain are the values of x. That's the independent variable. Remember that a function is made up of 2 variables. Your y equal to f of x. So your x is called the independent variable, while your y is the dependent variable. All right, this y now is equal to f of x. So if I write f of x equal to, say, 2x, so you note that this f of x is my y, so it is depending on my x. Okay, right now, so the domain of a function refers to the values of the independent variable, that is x, such that the function will be defined. In other words, what will the value of x be in this function that will make the function to be defined? Defined in the sense in this case means to make meaning. Okay, so that is to say, when it comes to a fraction, for a fraction to be reasonable, the denominator must not be 0, and that's why we are defining the domain in this form. So that means any value of x is allowed so far as that value of x does not make the denominator to be 0. So that's actually how. So once you are given a fraction, just pick the denominator. So in solving this, I'm going to pick x squared minus 4, and I will state that it must not be equal to 0, and then I will solve that particular inequation, and whatever I get will be my solution. Okay, so in other words, if you are given something like a over b, so the a over b is going to be defined if my b is not equal to 0. All right, okay, so now applying that rule, you are going to state that your x squared minus 4 must not be equal to what? 0. And in that case, so if I solve, I can actually go this way. I can decide to say, let my x squared plus minus 4 be equal to 0. So I'm going to solve this equation, and any value of x that I will get here should not be part of the domain. That's actually what that means. So that means I should solve this one, and in solving this, there are two ways you can go. You can choose to use difference of two squares. You know that I can write this as difference of two squares says if I have a squared minus b squared, that it is equal to a plus b multiplied by a minus b. Okay, so that means I can write this as x plus 4 multiplied by x minus, sorry, not plus 4 this time, sorry about that. Okay, first of all, change it to difference of two squares. That's going to give me x squared minus 2 squared is equal to 0. So that means I can write it using this. I can write it as x plus 2 into x minus 2, and that it is equal to 0. And of course, and of course, if I do that, then by quadratic equation, I will say that my x plus 2 is equal to 0, or x minus 2 is equal to 0. Okay, and if that happens, then I will get that either that my x is equal to minus 2, or that my x is equal to plus 2. Okay, so now that I have gotten the values of x that will make this to be 0, then my domain, therefore my domain is domain of that f is going to be equal to the values of x. That means it's going to be all values of x except x equal to minus 2 and 2. That means for all, sorry, let me put it this way, all x in R. That means if you go up where I define, that's at this point, you should put that condition, all x in R, such that this happens. Okay, so that's where my R is set of real numbers. So all x in the set of real numbers such that x is not equal to minus 2 and 2. And how do you write this? Because this one way of writing this is actually our solution, but then there are other different ways you can write this. So I can actually write it as R without minus 2 and 2. So this backslash here means without. So I can write this way. There's also another way. I can actually also write it this way, R minus. You know minus means without. Okay, minus this set, minus 2 and then 2. So any of these three representations is equal to my domain. So my domain now is the whole of the real number except minus 2 and positive 2. In other words, what that means is that any other real number you put in this function is going to be defined except 2 and minus 2. And of course, you can check it. If I put my x as 2 here, I'm going to get 4 minus 4, which is 0. And I don't want the denominator to be 0. And the reason why you don't want the denominator to be 0 is because if you put your denominator here as 0, and whenever you divide by 0, it gives you, an undefined value. If you use your calculator, that's when you begin to get math error or sign error. You get the point now. So that is a value for number 1. And so we go to question 2. I like to use question, Q2. So Q2 says, if f of x is equal to 3x plus 3 over 2, then find the inverse of f. So another way they can write this is just to tell us to find f inverse. You get? So either ways you should know that they are asking for the inverse of f. All right, so what do we do there? Now let's begin. To find the inverse of a function is very, very simple and beautiful. How do you go about it? Just follow me. Now, first thing is write down the function you are given. F of x equal to 3x plus 3 over 2. Permit me to draw a line here so that I will do it here and here. So in doing this side first, what do I do? Very simple. So first of all, there are about few steps that you are going to take. First, replace this f of x with y. Remember I told you earlier that it is the same thing as y. So I'll replace it with y. That's first step. You can actually document those steps here. Replace f of x with y. So if you replace it with y, what's the next step? Make x the subject. So let's try to make x the subject. First, multiply through by by 2. If I multiply through by 2, I am going to cancel out this fraction. So I'm going to get 6x here. Then the 2 will cancel this to give me only 3. So let 3 come over here. That will be 2y minus 3 is equal to 6x. Now divide through by 6. If I do that, I will get that my x alone is equal to 2y minus 3 all over 6. Beautiful. So remember, our second step is make x the subject. Make x the subject. That's the subject of the formula that you have. And then the third and the last step, or no, that's not the last step. Anyway, that's the last step, So what do? Interchange x and y. So if you interchange x and y, you are going to have y is now equal to, that's even if you have more than one y here, assuming there is another y here, anywhere you see y, just replace it with x. So that's going to give me 2x. Let me use white there. So that will give me 2x minus 3 all over 6. Now, look at why I said that is the last step. Interchange, let me write it. Interchange x and y. So look at why that is the last step. This y that you have here now is not the original y you were given. This is actually the f inverse that you are looking for. Therefore, just remove it and replace it with f inverse. So our f inverse of x is therefore equal to 2x minus 3 all over 6. And that is the required solution to that problem. So remember the 3 steps there. That's why I decided to tabulate them for you here. So first is replace f of x with y. The reason why we are making that replacement is so that it will be easy to juggle over it here. And then secondly, make x the subject. When you do that, then lastly interchange your x and y, and whatever you have is your f inverse. Okay, so that is for number 2. So let's go to question number 3. Okay, for number 3 we are asked to determine another domain. So here we are asked to determine the domain of the function f of x equal to the root of 4 minus x squared. Right, so sorry about that distraction. So we have for number 3, we should determine the domain of the function this. Okay, so solution. Remember I said something about domain, that domain of functions is actually defined depending on the type of function you have. The first one we talked about is when you have a rational function, that's a fraction. Okay, so we said the denominator must not be 0. That will guide you to get the domain. Now what if you have a radical function like this one? Now it's very simple. If we have radical of a function, say f of x inside, now, or let me use g of x. So since this is my own f, now f of x is equal to this. So and a function is under the radical. Now the domain of that function f is equal to, now remember this radical is always reasonable, will always give you a value only when you have either a 0 or a positive number. Once it becomes negative under real numbers, then it will not be defined. It will only have a value if you are talking about complex numbers, but in terms of functions we are just talking about real numbers. So in other words, the domain is all the values of x such that all the values in real numbers such that your g of x will not be negative. That means for it not be negative, it means it should be greater or equal to 0. That's the meaning mathematically. For a number not to be negative, it has to be greater or equal to 0. All right? So this is all you need. So in other words, to solve a problem like the one we are given, just pick everything under the roots and then state that it should be greater or equal to 0. Once you do that, solve the resulting inequality. Whatever you get is your solution. Let's quickly go into it. So what do we do here? Take minus to the other side. We have 4 is greater or equal to x squared. And then at this time, you can take your 2 to... Meanwhile, we can turn it the other way around. So we can have x squared is less than or equal to 4. And then, so by the time you take this to the other side, you are going to get... now, meanwhile, it's actually going to split in 2. Okay, so but let me just use this way to just explain it. Still keep your sign this way, but if this one comes over here, it will become the square root of 4. But remember that square root is always plus or minus, so that means you're going to have that x is less than or equal to plus or minus 2. But then it's not going to be right to keep both of them on one side, because it won't make sense. X cannot be less than or equal to 2 and at the same time be less than or equal to minus 2. It's not possible. If x is equal to 2, it cannot be less than minus 2. That's not possible. So because of that, you are going to pick the negative one to come across the other side. So your minus 2 will come over here and be less than or equal to x, so that it can complete the solution set. All right, so that is exactly what your solution is. Minus 2 must be less than or equal to x, and x must be less than or equal to what? Positive 2. And there are different ways also that we represent when we have inequalities. We call them representation of inequalities in interval form. This you should have done in Math 101, that's elementary mathematics 1. Okay, so and how do you represent that? When you have less than or equal to, you use close bracket. So what I'm going to have is close bracket minus 2 comma then 2 and then another close bracket, because the both sides have less than or equal to less than or equal to. Assuming that you have something like this, look at this. Let's take it that you have minus 2 less than x less than 2. Both of them are less, so you use open bracket minus 2 comma 2. But what if you have minus 2 less than or equal to x? Then this one is strictly less. The side that has less than or equal to will be closed. Then the side that has strictly less than will be open. And the same thing will happen assuming it is something of this nature. The side that has strictly less than will be open, and the side that has less than or equal to will be closed. Okay, so that's actually how we represent inequalities using intervals, right? So this is my answer, and it can also be of this form, and that's the solution to number 3. Okay, so let's go over to the fourth one. Okay, so look at the fourth example or question, The fourth exercise here says that if my f of x is equal to 2x squared and g of x is equal to 1 all over 3x squared, they said we should find g composition f of x. Okay, so this is what we are to find. All right, remember from the list of topics I gave you, the first question covered domain. The second question was inverse of functions. Now the third one was also on domain, and then the fourth one that we are now on is on composite functions. So you see, we are using these exercises to look at the topics that we have in this course. Okay, so how do you handle composition of functions or composite functions? I have f of x, and then I have g of x, and the question is asking me to get the composition of g on f. So first of all, remember you can actually remove that x there. That thing is just telling you the variable, just as you have g of x It's telling you the variable. So here we can just ignore it, and then we have not committed any offense. Okay, but just remember that you are dealing with x as the variable of this composition, because this composition is actually going to give you a single function. So meanwhile, let's interpret. What is the meaning of G composition f? It simply means G of f. Okay, so in other words, if you give me f composition G composition h, what does it mean? It stands for f composition f of G of h. So that means h is inside G, and both of them are inside the f. Okay, so once you understand this interpretation, then it makes your work very easy. You should be able to finish. So in other words, here I now know that I am going to start, the starting function is going to be G of x. So I'm going to begin with my G of x. What does that mean? Because it was actually this x that was removed and replaced with f. So you see that actually composition of function is a combination of two. So you need to know how to do composition, and you also need to know evaluation of functions, because that's actually what we are doing here. So you are replacing x with f. So meanwhile, what is our G of x? Our G of x is 1 all over 3x squared. Okay, so in other words, if you now replace my x with f, what it means is that if I come into the function, anywhere I see x, I will also replace it with what? F. So meanwhile, what is my f? So at this time, I can now bring in my f. My f is given as 2x squared. So that's going to be 3 times, now f is 2x squared. Then I will still square it, because that f was squared there. Then if I evaluate this, whatever I get will be my solution. Okay, let's do that. That's going to give us 1 over 6. If you did I say 6? 1 over 3. If you open this bracket, square will come on 2 to give us 4. Square will come on x squared to give us x raised to the power of 4. And so that is going to be equal to 1 all over, you open this bracket, you have 12x raised to the power of 4 as your solution. Okay, sorry, in this question there is no square. Sorry, where did I get my square from? I'm sorry, I just looked at it again. I mean on your G, there is no square on G. Sorry about that. So there's no square here. So this is just 3f. Okay, I just looked at it again and saw that there isn't any square there. Okay, so that makes the work much easier, because this is going to now be 1 all over 6x squared as your solution. Okay, so and that's the solution for question 4. Okay, and let's quickly look at the next one, right? So in the next one, which is question 5, what are we told to do now? Okay, that's another point I should mention here. Under functions, you are going to look at what we call piecewise functions. So we see some examples on piecewise functions. Okay, let's go back, because that's actually where the question is coming from. It's a combination of evaluation of functions and piecewise functions. Okay, so it says evaluate the piecewise function. What's the piecewise function given? Okay, they said at x equal to 1, if f of x is equal to, look at the f of x here, minus 2, where x is less than or equal to minus 2. Okay, sorry, x is strictly less than minus 2. And then the second function is 2x and is on the interval minus 2 less than or equal to x less than 0. And the last one is x squared plus 2 between x greater or equal to 0. Now, what is a piecewise function? A piecewise function is a function where we have two or more functions in one, and they are defined over different intervals on the real line. You can see that this starts from negative infinity and then to anything greater than minus 2, or sorry, less than minus 2. Then that means for any value of x less than minus 2, let your function be taken as this. That's the meaning of this. While the second one is saying for any value of x that is equal to minus 2 but less than 0, that's between minus 2 and less than 0, take your f of x to be this. Meaning for the first one, if I have x equal to, let's say, minus 5, it fell under here, so my function is going to be this. But in the second one, an example is something like x equal to, let's say, minus 1. You can see minus 1 is greater than minus 2, but it is less than 0. You can even use minus 2 itself, because they said x can be equal to minus 2 here. And then from here now, you can actually see the question they're asking us is here, because x equal to 1 is greater than 0. And so what that means is that you must be able to first of all determine the function to use. That's actually the trick under piecewise function. So in other words, since x is equal to 1 and x is equal to 1 is greater than 0, therefore our function is x squared plus 1. Immediately you determine your function, the question is done. Just get your f of x at x equal to 1. That's what that question is saying. Evaluate this function at x equal to 1. So this is the one we are going to use, which is 1 squared plus 1. And that's going to give us 1 squared is 1 plus 1 is equal to 2. Is it plus 1? Sorry, plus 2. Why am I omitting all of this? Okay. So this is plus 2 up there. Right, so you have plus 2 plus 2 plus 2, and so this is going to be equal to 3. Okay, so I think we are going to stop here in this section. So we've been able to cover 5 questions. Remember I said that there are 11. So in the next section we are going to take the remaining 6 questions, and then we will get into the second module. The second module has around, let me check, around, the exercises are not much. Oh, it has around 44 questions. Oh my God. Okay, so we're going to be dealing with the 44 of them in this particular channel. So the next time we will have another section, make sure you join. In fact, I'm just going to take a few minutes break and then I'll be back. Have a very nice day. See you in the next section. Bye.